So here's an exponential equation example. It's not economics this time. It's atmospheric pressure, and you can read about it. You don't have to know too much about it. Just read the question. This atmospheric pressure is given by this equation, and make sure you read what the variables mean. P of A, that's a function, is the pressure, and A is the altitude, and that's measured in miles. So it says the atmospheric pressure of Denver, which is called the Mile High City, so its altitude is 1 mile, is 11.9. We're going to use that fact to determine the atmospheric pressure of Mount McKinley, which is a very tall mountain that has an altitude of 3.85 miles. So that's the end game. We're trying to figure out the atmospheric pressure of Mount McKinley. So if you look at the equation, we need to solve for this K as usual. And that's usually where we use this initial condition. It says we're going to use the fact that we know the atmospheric pressure of Denver to get that K. So since it says in Denver, the atmospheric pressure is 11.9, and we know Denver is called the Mile High City, so its altitude is 1 mile, we can solve for K. So pretty simple here. You can just do it on the calculator. E to the negative 0.21 on my calculator. Second natural log, e to the, I forgot what it was already, negative 0.21 times 1. So I don't have to do anything there, is 0.810. So 0.810. And then to solve for K, I'm just going to divide both sides by 0.810. Actually, not only 0.810, since I already have it on my calculator, I'm going to get very accurate. I'm going to go 11.9 divided by this whole answer. And I got 14.6807. So K is 14.6807. I think that's what it read. It doesn't really matter. I'm going to use that from the calculator. You'll see. So now I'm ready to answer the question. The question is, what's the atmospheric pressure of Mount McKinley? So our equation is P of A equals K, which we just said is 14.6807 e to the negative 0.21a. Now it says the altitude of Mount McKinley is 3.85. So I'm just going to substitute that 3.85 in for A. And that's it. Now I can just figure out the atmospheric pressure just by typing this in the calculator. So I already have the 14.687. I am going to now multiply this by E to the negative 0.21 times 3.85, which is the altitude in miles. And there it is. The atmospheric pressure way up on top of Mount McKinley is 6.54. And that's, does it give us, that's pounds per square inch. So pounds per square inch. Now that's a much lower pressure than Denver. And it makes sense if you think about it. The higher you get, they say the air gets a lot thinner. So that makes sense. The pressure is a lot lower way up top on Mount McKinley. So there you go.